I've started recording as well.
Okay, thank you, Nambi. Hope I'm audible, Nambi. So we'll get started. Hi, everyone. I hope everybody is able to see my screen. Today, we are going to talk on Amazon Security Lake. So before we go ahead, a short intro about me. I'm Raja Krishnamurthy, and I have been working in Amazon Cloud since last close to 6 years. And I have been in the IT industry for close to 20 years. And I have worked on various technologies, starting from, I started my career as a programmer in .NET. So I moved from Microsoft .NET to SharePoint to Office 365 Azure, and then I have been specializing in AWS cloud since last 6 years. And within AWS, I have played the role of a developer, of a DevOps. And for the past 4 years, I'm specializing on cybersecurity. So I carry few certifications on cloud security and as well as a couple in AWS. And thanks to Nambi for inviting me to share what I have learned in the recent days with an amazing service around cyber analytics called Amazon Security Lake. So before I get started, this is actually a continuation of a session which we did in the last month with Nambi's audience. I know some of you are new to this today's session. So I just wanted to know if anybody has heard about Amazon Security Lake or has used Security Lake, or is it new for most of you? So can I assume that it's new for most of you? And I'll do a quick recap of what we did. Or anybody has used Security Lake from the audience?
No, for me.
No. Okay. So in the last month session, we had an intro about Security Lake. We spoke why it is needed and what's the value you get. So I'll do a quick recap and then I'll move on. So today we'll do a recap and then we'll talk about something called OCSF, Open Cyber Security Framework. Then we'll see how we can query the security data lake tables, and we will see some sample queries. And let's keep the session as interactive as possible. Please interrupt me. Let's have a discussion. I do not want you to get disconnected in the middle in terms of not following up of what I'm presenting. So all of us should be in sync so that the session is effective. So any clarifications that you need, please stop me in between. Yeah. So let's do a quick recap. In the field of cybersecurity, there has been a number of challenges, especially post-COVID. There have been almost every day cyber attacks. At least every week, we see a big organization becoming a victim of cyber breaches. So there are a number of challenges in cybersecurity. One among them is accumulation of data, which is relevant for cyber. So what is the cyber data that we are talking about here? So it's usually when we say data, it's documents, it is the database, or it's a consumer data, and we all have developed data lakes and data analytics, data visualization. So we're trying to do the same, but for cyber data. So when we say cyber data, what exactly it is? So the users, right? Users access applications. There are users who try to compromise. There are malicious users. So studying their patterns, user behavior patterns, clickstream data, or an audit data. So the navigation of users and the logging of what user did when. So this is a data which would be very helpful for security teams. So, so though it is not directly a cyber data, but it's very much relevant for your cyber posture. So this is one type of data. The other is the logs that applications generate, the logs which are logged by the infrastructure components in cloud. Say a CloudWatch logging a series of data, or the logs generated by networking components like a firewall, or the VPC flow logs. So these are relevant. These are needed because when we do investigation, these logs would help us. So this is the cyber data. Then when applications are scanned, so we get a vulnerability report. That's again a cyber data. Then networking. So we gave an example of networking data. Next is most important, very relevant for this topic is the threat intelligence. So there's a lot happening outside the organization's premises. So in the internet, constantly there are feeds getting generated, getting reported, saying so-and-so malicious IP address is revolving around. So be cautious. If you find these IP in any of your logs, then it is something that you have to block immediately. Or there might be a vulnerability which would have got reported. So that's an intelligence. So these kind of feeds, you have to be aware of what is happening outside your boundary as well. So when you are working for an enterprise, cyber data is not just the data which is generated within the enterprise. It is also what is happening in the outside world. So you should be very much knowledgeable aware of what is happening in the outside world. So one such resource is the threat intelligence. So there are a number of open source threat intelligence platforms. They give you APIs. So you can constantly keep checking for these APIs and see if there are feeds which would be relevant to you. Yeah, so these are some of the examples, not all, but these are some of the most widely used or the kind of data that we come across in our day-to-day life. So are you all with me? Any thoughts you want to exchange around cyber? Anything you feel is relevant as to be called as a cyber data, please to come forward. Okay, so that was around the data, and what has that got to do with Amazon Security Lake, right? So the type of data that I spoke about, the list is quite enormous. When an enterprise goes into production, giving access to users across the internet, having thousands of internal employees, you can imagine the volume of data that gets generated. Now, making a sense out of this data is a challenge, and Amazon came forward with a service called Amazon Security Lake, which was announced last year in the reInvent, and it's been close to this June it came into GA, so it was available for public consumption in the month of June this year. So it's been like 4 months, close to 4 months since it has come for public consumption. So let me give you an overview of what it is and why it has been launched. So the primary objective of Amazon Security Lake is to bring all of the data which we saw in the previous slide. It has the capability to bring all of them in one single location. And the AWS generated data, or the data which are generated by or within the boundary of AWS will be automatically, or most of them will be automatically consolidated by Security Lake. But the real value of Security Lake is in bringing external data. Like I gave you an example of threat intelligence data, which is it's outside of AWS. Or there could be a log from an application which was developed by you, and say it is in some other cloud platform, or it's hosted within AWS as well, or it could even be at on-prem. You can ingest data from those non-AWS sources as well. So the source from where you ingest data can be anywhere. It need not be in AWS. It can be in another cloud platform. It can be in a SaaS application, or it can be at on-prem. The source can be anywhere. Security Lake has the capability to ingest these kind of data, and you can consolidate as a single source of truth. And of course, there is a guiding principle behind what kind of data it can understand, and if it cannot understand, how we can make it understand. So that's where the whole gamut of open cybersecurity framework comes. So I'll explain what it is and how we can use it so that Security Lake interprets the log data, and it can consolidate and bring it into one single location. So once the data has been consolidated in a central location, we can do analytics using any tool. So it need not be an AWS service like an Athena, it's not that you have to do data visualization using a quick site. Whatever tool you have, you can use it, and you can do data analytics, you can do data visualization, or you can have a downstream application which can consume the data which is consolidated by Security Lake. Because at the end of the day, all the data resides in S3 buckets. And S3 has the flexibility to expose the data through APIs. We can write wrapper on these APIs, and we can build in whatever fashion we want. So that's a gist about Security Lake. Any questions so far? Are you all with me? Okay, so I'm assuming that we all are good. Okay, so I'm going forward. We spoke about data, right? So we spoke about AWS generated data. We spoke about data from another cloud. So this was all about the data created within the applications or within the infrastructure. Now, apart from it, if you take an enterprise, and on an average, it has been found that there are 76 security tools. So when I say security tools, I refer to ISVs, independent software vendor tools, like a Palo Alto firewall or a Symantec DLP, or Okta identity access management. And then, of course, the SIM tools, a number of third-party tools you would see in an enterprise when they go into production. IDS tools, IPS tools. So it's a long list. Now, it's a humongous task to make a meaning, create a meaning, or create an insight out of these tools. So what is happening today is all of these tools are generating data, and it's in silos. There might be teams who will be making sense out of this data, but it is not brought into a single source or into a single location. The survey says, and I think it is from Thomson Reuters, if I'm not wrong, it on an average there are minimum 75, 76 tools which an enterprise use. So you can imagine the challenge in managing these tools, and above all, each of these tools are from independent companies, independent vendors, and the data generated by these tools are different. They all talk different schemas. For example, if there is a checkpoint firewall, it might call the IP address as say IP-ADDR. If there is WAF, web application firewall, it might call IP address as SRC_IP, but both are IP address, right? So, but the tools will expose the IP address in their own fashion. So each of them have their own schema, and there is no common schema that they talk, or common schema in which the data is organized. So when you have to bring data from these many discrete sources into a single location, it becomes challenging in terms of if you want to normalize the data, you will not be able to do it. It will be in the sense you have to do a lot of customization, and you have to spend a lot of time in managing it and converting the data schema. And it's quite a challenging task to do. And that's the reason why we have OCSF, Open Cybersecurity Schema Framework. So Splunk and AWS came together, and there are other organizations as well. They created an open source project in which they have come forward with OCSF standard. It is an open standard. It's a common schema that any not only just cybersecurity data, any data which you want to ingest into a cyber lake, that data has to follow the schema. And there is a defined way in which the columns have to be called. So if there is IP address, the OCSF will have a column name for that. And when you are ingesting or when you are converting data from a tool, you have to make sure that you follow that schema. So the good part here is, though I have put 60 here, as of today, close to 75 ISVs have ensured that the data that their tools generate is already OCSF compliant. But still, when you work for a business, when you work for a customer, there might be legacy applications which will not be OCSF compliant, or that could be a unique local vendor tool which may not be OCSF compliant. So in those instances, you might have to do an ETL job to convert the schema of those applications or tools into OCSF. So there is a guide which I'll show you. I'll show you how you can read the guide. So there is a GitHub link which explains what OCSF is and what is there in OCSF, and what are the guidelines to follow, and what column names. So I'll show you all that in detail. But that's the overview. That's the crux about OCSF. So in a nutshell, it is a common schema which every data source has to comply by.
Rajiv, quick question regarding this OCSF standard that you said. So every ISP vendors are started to follow the standard, right?
Yeah.
And for tools like container runtime security, so if we have a third-party tool which is running a sidecar container, and then splitting the logs. I think those logs should be on this format so that it can be collected in the security lake, and we can take the meaning out of it.
Yeah. So whichever tool you are using to generate the container logs, and you have to check whether that vendor is listed as a source partner of Amazon Security Lake. If they are, then you definitely they are OCSF compliant. If not, you can check with the vendor website or documentation to check whether the logs are OCSF. If not, I'll show you how you can convert to OCSF. So you have to do a small ETL work, which will keep on running. And as and when the fresh data is generated by the container vulnerability scan tool, it will keep ingested into Security Lake.
Thank you.
Okay. Any other questions? Okay. So in a nutshell, OCSF helps us to do analysis. So it's about having a seamless data exchange. You can aggregate different data in a single cyber lake. So you actually end up developing a cyber data lake, and then you get to do analysis. So it's vendor agnostic. So because it is a standard, it's a common standard, you don't have to worry that this tool is from vendor A, this source of data is from vendor B. So it helps you to be vendor analytics agnostic. And then, of course, it helps you in ingesting data. So integration becomes easy because all of the sources are following a common schema. You can quickly do the integration, which is the ingestion. And because of this, you are able to correlate. So that means you are able to mix and match different data sources and create insights out of it. And faster analysis, and you are able to simplify the normalization. One important point is, though we all are talking about cyber, the data source, it need not be a security data. For example, Nambi, you brought in the example of a container log, right? So container log, that tool may not be a cyber tool. So it's not that this OCSF should only be looked for, or it only works or for a cyber tool. The data source can be of any nature. It's just a question of converting the schema. Okay, so I'm moving forward. So let me show you what this OCSF is and how you have to interpret it, and what reference materials we have in the net. I'll just go off camera for a few minutes so that it's faster. I hope it's okay. Okay, so I'm just opening up a Git link.
We lost your screen share.
Yeah, I'm sharing. Let me know if you're able to see my screen. Is my screen visible?
Yes.
Okay. So this is the link I have given in the PPT as well. So there is a GitHub link for OCSF, and this tells you. Do you want me to put this in the chat window? I'll do that. Oh, sorry. It is in the PPT, or Nambi, you can share this link, because when I project the chat.
Yeah, I'll post it in the group, and I'll also I think we can upload the PPT as well at the end of this.
Okay. Yeah, wonderful. So this you can refer this GitHub link. It talks about OCSF framework. It gives an overview of the open source project, and then here you have the framework, right? So you just click this link, and it will take you, it will give you certain, there's a PDF, it's a long PDF. It talks about what is the OCSF taxonomy. You can read it, but it's not all that required. If you want to have a deeper understanding, you can very well go to the read the PDF. So in the GitHub, in the home page, you will find this link, schema.ocsf.io. So this is the home page. So this is the page where the entire OCSF schema is given. So on the left, you will see the versions. So the latest version is the RC.3. And here you will see these categories. All right. So these are the various categories of the cyber or any data source. For example, system activity, file system activity. So if you click this category, it will tell you, it will give you the schema, of course, and then it will give you an example of what this category is about. So this category of OCSF is for the data which logs about file modification. So you might have come across tools for file integrity monitoring. So there will be OS files or any nature of files which carry, say, the credentials, or even any of the kernel files, right? So in the cyber world, a very famous technique to compromise is tampering the files. So enterprises invest on file integrity monitoring. In the AWS world, you have FSx Luster. So we use this for storage of files. And FSx has something called file access audit logs. So that can be an example of file system activity. So what you could do is you can ingest the FSx logs into Amazon Security Lake, and you can do analytics on top of it. Or if you have a third-party file integrity monitoring, which many customers, many enterprises have invested on, so you can take the schema of that tool, and if that tool is not OCSF, you can keep this schema as a reference, and you can work on converting the schema of the tool into the schema which is matching the file system activity class. Similarly, a very common used category is security finding. So security finding, if you see in the AWS world, it is Security Hub. So Security Hub is a CSPM tool. Now, many enterprises might also have third-party CSPM tools, like they will have a Prisma Cloud CSPM or Wiz. So there are a number of CSPM tools. Now, you can bring the findings from these tools into Amazon Security Lake. And again, if they are not OCSF, then you can refer the schema and you can write code, or you can write the ETL job to convert the schema which is compliant with this. Now, there is a way, to make our life easier. There are API documentation available. So you just click here and you go to the API documentation. So here you can also, so when you try to automate things, right? So you cannot manually come here and copy the schema. That's not going to work. So there will be automated way of downloading the schema and then interpreting the schema and then doing the ETL. So OCSF exposes APIs which you can consume in your code, and you can download the latest schema and then you can do your ETL. So I'll give you one example. Say, for example, I want to programmatically download the schema of, say, security finding. So this is the security finding class findings category, right? So here I can copy this. So this is the code for security finding class, and then say I want to get the sample schema. I can say try it out and can give the name of the class, execute. So here I get the schema of the security finding. This is a sample schema. Oh, sorry. Yeah. So let me format it. So here you can see these are the fields of the schema. And you in this table, you will know which is mandatory. So here you check the requirement column. Most of them would be optional. So if your tool is not, if your data source is not having these columns, it is fine. But there will be certain columns which are mandatory as well. So these are the required columns. Let me sort it the other way. Yeah. So these are the columns which are required, which you must have, and you should ensure that the tool or the data source that you want to ingest into Security Lake has bare minimum has these columns, starting from type ID, state ID, severity, metadata, finding event time, class ID, category, and activity ID. So class ID is the number which is given to the class. So we chose security finding. So 2001 is the class. So if you want the numbers that you have in the bracket, they are actually the class ID. So when you are converting, when you are doing the ETL job, you can hard code this number, and you can fill that column. And the other columns are defined here. So for example, since it is a security finding class, it is must that you have a security ID column, and it's an integer column, and these are the probable example numbers and what each number means. Similarly, you should have a metadata column, and the metadata column is an object, and the metadata object should have these columns. So basically, it just means that the source, the data source or the schema that you want to ingest, it should comply with these column names. As long as it does, a security lake will be able to interpret it, and it will ingest into the security lake. So are you with me? Is it fine? We're able to follow? Okay, so any questions? Okay, so security finding. Yeah, this is again another interesting view. Let me share my screen once again. Okay, so the security finding, you will also get a visual representation of what this class is about. So if you come here, This is the security finding class, right? So it has these columns, resources, API, enrichments, findings, and what each column is. If this finding is a object, so it has the finding object and what that finding object should have remediation and related event. So basically, it gives you an understanding, further insights into what each column is and what kind of information it is expected to have. For example, malware, vulnerability details. So third-party tools, right? They will have these data maybe in some column name. All you need to do is to ensure that the schema that you are reading is converted to this OCSF schema if the vendor is not supporting as of today. Now, you might want to know which vendor which vendor generates OCSF data, right? So it's very simple. Just go to Amazon Security Lake Partners. So you will hit the AWS website, and this is a growing list. So as of today, these are the partners. So when I say Aqua Security is a source partner, it means any data which is generated by a tool from Aqua Security is OCSF compliant. So you don't have to invest time on doing the ETL job. All right, so you can read it here. So integration of Aqua Security and Security Lake utilizes the OCSF format. So there are many scanning tools which I have come across in Aqua Security. You can bring in those data into Security Lake. Barracuda Firewall, Cisco, then Clarity, Confluent, Cribble, CrowdStrike. So this is the list, and it's a working list. So many partners get added every month, so you can keep checking. So source partner means data from these tools can be ingested into Security Lake. Subscriber partners, it means those tools which can read Security Lake. So they will subscribe to Security Lake. So they will be consumers of Security Lake. Very famous example is a SIEM tool. So say Splunk. Splunk is very commonly used by customers, and it is a SIEM tool. You can do analytics, you can do visualization. It also offers machine learning models. You can do user behavior analytics. So you can actually connect Security Lake with Splunk out of the box. So Splunk has a connector already in its product for Security Lake, and that's how they got listed here. So you can use that add-on, and you can out of the box connect Security Lake with Splunk, and Security Lake will make sure that the data, whatever data is needed for the enterprise level cybersecurity posture is available, and you can use Splunk for SIEM. So that's about the source, and the subscriber are the main ones that you would be interested. Service partners are SIs, GSIs, service industry organizations who have earned their credential to get listed here. So it means that they have worked on Security Lake, they have evaluated, they have offering solutions around Security Lake. So that's the credential. Okay. So any questions so far? Is my okay? I think my is my PPT visible?
No, I think your browser is visible for us.
Yeah, browser is visible. Okay, okay. Let me. Yes. So any questions? You all are good.
Raji, this is Karthik here. I have a question.
Since you said like the third party solution, SIM solutions, right? In such cases, do you have to aggregate it before SIM and then pass it on to the SIM tool like the security lake?
Before, meaning I didn't get your question.
So here is a scenario. If I have many security devices in AWS, which include security services of AWS as well, right?
Yeah.
And assume that I have to send it to the SIM tool, let's say Splunk. Okay. In such scenario, do I have to take security lake and convert this into the format, then send it to the tool, the Splunk tool, or Splunk tool itself has this capability?
Okay, this slide will answer you, right? So you said that you have a number of tools on one side, and say, let's take a scenario where there is no security lake. So what you would do is you will create a connector, and it is your job to ensure that the connector is configured correctly and it's working fine, and you have to maintain the connector. And that connector will ensure that data from the AWS source or any source for that matter is fed into Splunk. Now that you have security lake, you have to ingest the data from your source into security lake. So that part you have to make sure. Whether you do custom ETL or it's already OCSF compliant, that's a second question. But you have to bring the AWS source or any native source data into security lake. And from security lake to SIM, I showed you in the website, right? Splunk has a connector for security lake. You have to configure that connector. So if you don't have security lake, for each of the source, you will have these many connectors. With security lake, you will just have one connector with Splunk. Does it answer your question?
Answers very much. Thank you.
Okay.
Raja, I have a quick question. You said the data would be pushed to security lake and from there to Splunk, right? Would this be not a redundant because the data would be stored in two places? Like I would have it in the security lake as well as in the Splunk. Is it not a redundant and it would add the cost to a storage cost for the customer?
No, actually, it solves many problems. So this is a connector, right? So in security lake is within your cloud, it's within AWS cloud, and now because it is within the premises of the cloud, I don't have to worry about sending data to a Splunk. So traditionally, what's been happening is we send, say, 3 months, 6 months of data into Splunk. Now that we have security lake, we get to send only the data that we want. So, for example, 30 days of data, because the functionality of Splunk is only for data analytics and visualization. I may not require to do analytics for 6 months of data, not every time, until there is an incident and there is an investigation needs to be done. I will not do analytics for 6 months or 9 months of data. So when we have dashboards created on Splunk, it would mostly be for the last 15 days or last 1 month, right? So we can minimize the data which is sent to Splunk, we can minimize the data which is sent outside of AWS into Splunk. So that's the advantage that we have. And within AWS or within security lake, I can have 1 year of data or 2 years of data. That's up to me. But when I'm sending to Splunk, I can control. I can say last 30 days of data or last 45 days of data. So that's the advantage I would get here.
Yeah, thank you. Thanks.
Okay, so we spoke about external data. We saw OCSF. Now let's see what OCSF we have in the AWS sources. So these are see this list that you see on the left, which is source. This is a growing list. There are in the roadmap of Security Lake. I've been hearing talks about including WAF logs, load balancer logs. So I think in the reinvent we will get a bigger list of sources. But as of today, this is what it is. So the data generated by CloudTrail, it is of course already OCSF, and it is mapped against the API activity. So in the schema website, if you remember, we saw a table, we saw a class, we saw a category, right? So there is a class for API activity. And if you check it, it will give you, the website will give you the list of columns. Now, CloudTrail, AWS has already mapped it against API activity. Similarly, CloudTrail management events. So the earlier one was the data event. This is the management event. This management event is mapped against API activity, authentication, or account change. So what it essentially means is the column names, the columns which you will see in the Amazon Security Lake for CloudTrail management events, those columns will be same as the OCSF schema defined for API activity. Got it? So similarly, for S3 data events is API activity, Route 53. So the data generated by Route 53 is mapped against the DNS activity class name. Security Hub is, of course, it's understood. It's a security finding class. Then VPC flow logs is mapped against network activity of OCSF schema. So this is the story about the AWS sources.
And these list would grow, is it? Because we do not have for RDS.
Yes, so this list is a growing list. So there are talks about including WAF logs also. So what does it actually mean is when you enable now Security Lake is just like another service in your console. So there is a process by which you have to set it up. So there are user guides available in AWS documentation. So once you set up Security Lake, without any effort, the sources which you are seeing on the leftmost column, they would be automatically available in the Security Lake database. So once you set up Security Lake, you will get a glue DB created, and in the DB you will have number of tables, glue tables. So each of the source which you are seeing in the column, each row will be a table. So CloudTrail, there will be a table for CloudTrail management events. There will be a table for Lambda execution. There will be a table for S3. One table for Route 53, one table for Security Hub, and another table for VPC flow log. So each of the row will have tables and under a common database called Security database. So all this I'll show you in Athena. So in Glue, these tables are created. So all of these tables will be automatically created. You don't have to invest any effort. So that's what it essentially means.
So Raji, question. So at the moment, the prominent security services like Guard Duty and WAF logs, right? Are they not compactable or they are not integratable as on date?
The Security Hub findings, it ingests logs from AC, from Guard Duty. So since Security Hub is fed into Security Lake, you will get the Guard Duty findings.
Got it. Thank you.
Yeah.
How about WAF logs?
WAF logs is not fed into Security Hub. There is a roadmap saying that WAF log will be added as one of the additional news source. I think we have to wait for a reInvent announcement, or maybe they will announce before. But I heard that WAF logs will also be added as one of the source.
Great. Thank you.
Yeah. So again, if it is not a source as of today, if you want to ingest something which is generated by AWS and it's not a source by default, you can always do a ETL and convert to any of the class. So WAF log, check in the OCSF schema if there is a class for firewalls. If not, then you can see which schema is most suitable for you and you can map it against it. Okay. We already spoke about this. So, when customers have a SIEM tool, it makes all the more sense to bring in security lake in between. One is, of course, you don't have to manage so many connectors. You will have just one connector, and this becomes like an intermediate entity, right? And one is connectors, and the other important advantage is controlling the volume of data that we send to Splunk. And in Security Lake, it has a capability to do optimization. When you set up Security Lake, you will be given an option if you want to store at a time 30 days of data and then move the older data to S3 intelligent tiering. So there are various ways in which you can optimize the data and archive it. Like when you optimize data, you will send lesser volume of data to Splunk. That by it will help you to bring down the cost, because cost is a pain point many organizations talk about when it comes to SIEM tools. And the third advantage is because we are controlling the data which is crossing the boundary of our cloud environment, it directly solves many of the compliance challenges, the regulatory challenges. And that's another major advantage of bringing in Security Lake in between. Okay, so are you all with me? Shall we go to the Security Lake console? Any questions, please let me know. So I'm sharing, just give me a moment, I'll share the console. Yeah, so let me know if my screen is visible. This particular account already has Security Lake set up. So there is a big user guide. This quite self-explanatory, getting started with Amazon Security Lake. So there are a certain prerequisites for it. Okay, so it works best, though it's not mandatory, but from my experience, I would say have a landing zone set up, have a master account, have shared services account, and then you should have accounts for applications. So have a good landing zone set up, and then you bring in Security Lake. At a bare minimum, you should have at least 2 accounts in your landing zone. One is the master account, of course, and then there should be another account where you can set up Security Lake. So that would be an ideal scenario when you have a separate account for Security Lake. Usually in enterprises, when we set up a landing zone, we will create shared services account. We'll create one account for logging, one account for audit, one account for security. So you can either choose the logging account or the audit account or the security account. You can choose one of those existing accounts and you can enable Security Lake in that. One important aspect which I missed was Security Lake is a region specific account. So it's not a global account. So when you enable Security Lake, say in Sydney region, all of the accounts from Sydney region, all the accounts in the landing zone will send their data to the security lake. So all the Sydney region data will be sent to the security lake account automatically. And if you want data from other regions as well, there is something called roll-up region. So you will come across when you set up security lake. Yeah, I think it is in the integrations. So you will come across it in one of the steps of setting up security lake. You can add other regions as well as a roll-up region. So the additional region data will also get automatically ingested into security lake. So that's a quick just about the setting up. So you can follow this guide. In my last session, we did a walkthrough of this, so you can refer that as well, or you can reach out to me offline. But this guide should be sufficient. So once you set up security lake, let me show you Glue. So you can see here, this DB, once you set up the lake, you will automatically see this DB created. So this is the database that Amazon Security Lake Service creates. And inside this database, you will have all of the sources. So each source, as I said, it will have a table for its own. So this table which you are seeing, CloudTrail management, this is the CloudTrail management table. Now, reason why you're seeing 1_0 is because we started using Security Lake when it was in preview. So after it came into GA, it created a new table under this name. So you will not, I don't think you will see 1_0 when you set up now. It will just be CloudTrail management. So each of the table corresponds to each of the source that we saw in the earlier slide. Yeah, so Lambda execution is one table. Table for Route 53, table for S3 data events, table for security hub findings. The other tables are all the custom tables, the custom sources or the non-AWS sources, which I have ingested into Security Lake. So that's why you're seeing the other tables here. So if you see here, you can see the schema. So CloudTrail management is API activity, right? So this is the schema of the CloudTrail management event. So similarly, you can check the schema of other tables as well. Okay, so you will get these tables. Now that you, after you check the tables, all you need to do is to do analytics. So you can join different tables, you can create visualization. So here for our session, I'm just using the AWS services. So I'm using Athena for writing the queries and QuickSight for the visualization, but it's up to you. Whichever tool you have, you can use it for the analytics and the visualization. So I'm in Athena, and I have written some queries which I thought I can show you. So this is the database which I've selected, and these are the tables that are there. So whatever you saw in the Glue in this console, all those all of these tables you get to see here. So one thing which you should know is you should understand the column, the data type of the schema. If you have written SQL queries, it becomes very easy to write Athena queries. Let me show you some sample queries. Share the entire screen, it becomes easier that way. Okay, you can see my screen, right? My slide is visible.
Yeah.
Okay, so when you start working with the tables, you will come across some columns which may not be familiar unless you have worked extensively on database. So some columns will be array data type, some will be struct, some will be say sometimes it's just a straight string, sometimes it is nested. So there are certain data types which you must be familiar with, some functions, so that your life becomes easier when you start writing queries. So I've just brought 3 example columns. So if you take, say, here we have the cloud trail management table. So let's see what columns it has and how you can crack the array column, because I have spent quite amount of time in framing this query itself. So I thought I'll show it to you so that you save your time. Okay, so say I want to query the cloud trail management table, and the cloud trail management table is here. This is the schema of the cloud trail management table, and these are the columns. All right. Now I want to. There is a column called. Okay. So there is a column called resources. So the resources data type is an array. Okay, so you cannot say select resources from table. So there are certain functions that you have to use. So whenever you have an array column, you can use the unnest function to unnest, because this is a nested array, will be like a nested column. Inside resources that you will find like a nested JSON sort of a string. So you can use the cross join unnest function, which will decode this resources column, and it will give you the result. So this is one simple query. All it does is it selects the 5 rows from cloud trail management column, and it will show you the resources. So when you run this query, I'm selecting time, cloud, API, and this resources is mapped as R. So R dot, I'm selecting the UID, account ID, and the type. So this is the output. So this is the UID, which is the user ID. So there is a user or a role, whatever. So there was an API action, because CloudTrail is all about logging the API action, right? So this is the UID of the user / role, and this was the account ID, and this was the type. So I'm just selecting these 3 columns from the CloudTrail table, and this is the function that you have to use. So anytime you come across an array data type, you can use the cross join unnest. Another example is the time. Time column you will very frequently be using because you want to know what happened in the last 24 hours or in the last 15 days or between a specific start date to end date. So time you will commonly use, and in the security lake tables, time is the data type of time is Unix time. So it is not straightforward. You have to convert. Okay, so you have to convert for which you can use the from_Unix time function, and you will be able to interpret the time. So otherwise, how it is so time will be logged like this. So you cannot make out what it is, right? So it is in milliseconds. So you have to use this function from_Unix time so that you can interpret what the time actually is. So this is another commonly used column. So when you use the from_Unix time of the time column divided by 1000, because it is in milliseconds, you will get it in a readable format, which you will understand. Another example is on the struct column. Okay, so many columns you will find as struct. So here, what do we have as struct? So there is cloud column as struct, metadata is struct, SRC endpoint is a struct, user is a struct. So the example query that I have, I think it uses user. Yeah. So the user column is a very useful column in CloudTrail. It gives you information about the UID. It gives you as what the user logged in. Did the user log in using a role, a service link role, or IAM user or role? So all those information will be available in the user column. And the way you have to use it is you have to use the dot operator, because it is a struct data type. So you have to using the dot operator, you can get all the information like UID, UUID, username, and so on. So this is the sample query which we ran, and we got the output as this. So UUID is the entire ARN of the role or the IAM identity that was used, and this is the username. Yeah, so that's how you can use the struct column. And so far we have seen querying a single table, but the real value is not in the single table. Real value comes when you combine various tables together, and the maximum value is when you have external sources and you combine an AWS source along with an external source. I'll tell you why it's beneficial. Now, when it comes to cyber attacks, right? So there will be there are many ways in which attacks happen. Many new methods are emerging with AI and Gen AI. There are faster ways of compromising, and we also have to get smart. A common scenario is exploiting the vulnerability which an application has. So the application generates logs. That application could be hosted in AWS or it could be hosted somewhere else. Thanks to Security Lake, now we can bring the application logs into Security Lake. So these application logs is an external source for Security Lake. So once we bring it into Security Lake, this will also get listed in this list. This list that you see on the left, the external application logs will also come as a table here. And because all of these are in a single DB, you can write join queries. You can join the application logs along with CloudTrail. So why it becomes important is when somebody is exploiting the vulnerability of the application and they are able to penetrate into the infrastructure layer. So assume the application is hosted in a EC2 instance. So when a cyber attacker is entering into the infrastructure layer, say they are able to somehow get to know the IP address of the EC2 instance, or say the application is accessing an S3 bucket. So they are able to get into the S3 bucket or run a command against the S3 bucket. So these information will be logged in CloudTrail, or you can find these information in Security Hub or in VPC flow log. So when you are combining the application logs, it will tell you that in a certain time, there was a user who accessed the application, and around the same time, we saw a huge download, which CloudTrail told you. Or around the same time, there was a new vulnerability which got generated, which a Security Hub might tell you. Right? So when you write these join queries, when you do these correlations, so this is what we call it as a correlation. It's a series of action which takes place from one system to another. So as a SecOps team, as an operations team, you have to write these correlation queries and create dashboards upfront. And whenever these queries return data, whenever you see a value getting alerted in these dashboards, these would be an indicator of a compromise, or these will be indicators of attacks. It could be genuine, but it is something which the security team should be aware of and investigate further. So that's the real value of cyber analytics, and that's what Security Lake solves. So yeah, I think that's all I had. I think we should discuss. Let me know. Okay, this is one sample query. I have not brought a non-AWS example here. Here we are joining two different, or I think how many? Yeah, there are two different tables which we are joining, and both the tables are from AWS. So I'm joining the S3 data events along with Security Hub events. So whenever you join different tables, it's a SQL join. It works in the same principle. So there should be a common column or a common entity between them. It could be time, it could be IP address, or it could be the ARN of an AWS resource. It's up to you, however you want to. It depends on what insight you want to derive and how you are writing the query. The example that I have here is joining on the resources column. So S3 data has a resources column, and so does Security Hub findings. So we are making use of this common column, and I've written this joint query. So why this joint query was written? What it actually says is, what are the vulnerable resources? What are the vulnerable S3 resources which have been found in Security Hub findings? So Security Hub findings job is to alert the vulnerable S3 buckets, not just S3, it gives all, but here we are just selecting S3. So Security Hub will tell you what are the vulnerable S3 buckets. Now, with those S3 buckets, we are filtering for user agents which are not Mozilla and Chrome. That means if somebody is accessing a vulnerable S3 bucket, not through a browser, say it could be through a command line or any other way, right? So if somebody is logging or accessing a S3 bucket, which is vulnerable at the same time, then create an alert or create a dashboard. So that's the insight that we are trying to derive, and this is the query behind it. So, this is how we have to use the Cyber Lake, Security Lake, and do. This is just one small example of an analytics that you can do. Yeah. So there's a lot more you can do with Security Lake. I've just shown you what is possible. But yes, it's an innovation playground. You can come up with a lot of ideas, lot of dashboards, lot of queries. You can also bring in SageMaker. So what you can do is you can create prediction models in SageMaker. You can feed the security tables data into it. So it will help you in alerting anomaly. So when you feed in the security tables data, you will be able to create a model in which the model will learn based on the expected behavior, or whatever is the normal behavior. You feed it into the SageMaker Jumpstart or SageMaker model, and whenever there is a new kind of action, or whenever there is a deviation, it will give you an alert. So that's how you can create a anomalous detection with machine learning. So there's lots more that you can do. So I think we can discuss further any ideas that you have. Any questions, let me know.
So, Raji, that question is basically we have different type of log that we are feeding into security lake as table, and we are writing some query and getting some data out of it, right?
Yeah.
In a nutshell, to say. So, what is the purpose of running this query, and what this output where we are feeding us input to in the overall process? Say you are running some query, you ran some joins, we get some output out of it, right? That data, that output, where it is being useful, or how we can use the data for an inference for something else.
So what is the role that you are playing in AWS?
So I am basically working in infra.
Okay, you are
yeah.
You are an infrastructure administrator.
Yeah.
Okay. So security operations team, SecOps teams, they have dashboards created to know what is happening in the infrastructure or in the application layer, or a combination of both. So when we write these queries are written to bring out a certain suspicious activity, or to understand if there are any indicators of an attack happening, if there is any unexpected behavior happening. That's what these queries will tell you. So if you create say, I'll give you a simple example. If you create a quick site, for creating a dashboard in QuickSight, you need to give an Athena query. So you can write this Athena query, and then you can create a QuickSight dashboard, and the security operations team can use this dashboard as part of their day-to-day life. So this will be helpful for SecOps teams and operations teams.
Understood, but you are saying like this query will gives the indication of any malicious activity, right?
Yeah.
Does this VPC log or WAF log doesn't give this indicator? Only when we come into security gate, we get a clear picture. How does it stand over there?
VPC flow log, if you have queried VPC flow log, it will tell you which IP address was denied, which traffic was rejected, how many packets of data was sent, how many packets of data was downloaded. That's all it will tell you. When you are combining different tables when you join different tables, you get to do correlations. So to do correlation, you need different data sources. You cannot correlate with one single table. Correlation simply means a series of events. So the user is hopping from, say, if the user is accessing a S3, you will get to know, of course, in CloudTrail. But around at the same time, if there was any vulnerability introduced, you will get to know only with the security hub. CloudTrail will not tell you what vulnerability got injected or what vulnerability arose. So you have to combine a security hub and CloudTrail, right?
Okay.
Individually, if I query, I will not know.
Got it, Raj.
Yeah. So that's why when you have everything together in a single source of truth, you can do these correlations.
Okay, Raj. Thank you.
Okay.
Yeah. Okay, I think we are at the end of the session, Raj. I think we had a question from Mohammed as well. I think we could close for the day, and thank you very much for your time and sharing the details around Security Lake. And I think you are being keen supporting the group and sharing your knowledge. Thank you very much for your support.
Thank you. Thank you for inviting me.
Yeah, thanks, Mohammed, for joining. And I just want to say we meet every month, third or fourth week, Saturday, 11 a.m. And we'll have the topics decided and then have the experts presenting. And you can join us regularly as well.
Sure. Thanks both. Thanks for the session.
Thanks,
Yeah,
Mohammed.
Thank you.
Yeah, thanks a lot. Thank you very much. Thanks a lot.
Thank you.
Bye.